Hello, this is an introduction to EES, which is Engineering Equation Solver. You can download that from the source files that are on the course website and go ahead and install it. You can actually put it on like a thumb drive if you want and carry it around. You don't have to put it on your computer just when installing it. Choose the disk that's your thumb drive. When you first launch EES, you're going to see a screen such as I have up here where this equation window is going to pop up and there's going to be a series of options and a menu bar. And I just want to kind of introduce you and kind of poke you around on what the various windows look like. So first of all, as I mentioned, EES is a simultaneous equation solver, so you can just type equations in here. So if I type a simple equation like x equals 2, I can solve that equation for x, which obviously it's very simple. I can click this calculator button right here, which is solve, and then my solution window pops up and it tells me, well, simply x equals 2. So that was pretty simple. But, if I said x equals 2 plus 3, or sorry, 2 plus 5, and solve it, well, clearly it's going to tell me x equals 7. So all I need to do is type my equations in over here. They do not all need to necessarily be explicit. I could say 2 times x equals 45, right? And so I don't have it explicitly solved for x, and go ahead and solve that, and I find out my value for x. You can put in multiple equations in any format, so I'm just going to write down a bunch of equations here. So 27.4 equals x plus 2 times y plus 3 times z. So note a couple things here. The format, it's kind of like you would do in Excel. The asterisk here means a multiplication, pluses and minus clearly. I put some spaces in here that helps you see it, but those spaces are actually optional. So let me just type another couple equations. So I got 40.6 equals 2 times x plus 3 times y plus 4 times z. And now I have three unknowns, x, y, and z, so I'm going to need three equations in order for this to be solved. So I need to type one more equation. So the 53.8 equals 3 times x plus 4 times y plus 5 times z. So I clearly just kind of made up some equations here. I have three equations. There's three unknowns. None of them are explicitly written, and the algebra there is pretty complicated, but you could probably solve it given some time. However, we just click our solve button, and it's able to solve it for us, and here are our values of x, y, and z. So you can realize it's pretty quick and pretty efficient, and it's a lot easier than doing all of that algebra. Now that's one feature of EES, and the other thing it does is, as we'll see in future videos, it has all the thermodynamic properties that we need. But I want to point out a couple other attributes of it, which are various functions you can use. And so one that's helpful with this week's homework is a function called convert. And so the problem that we did in class wanted to convert 10 to the 15th, and the units were millimeters cubed Pascal per minute into horsepower. So I'm going to define my value P1 as 10 to the 15th. So I can call my variables anything I want as long as they start with a letter. So there was my initial power. And remember, that was in those strange units. So I could go ahead and convert that. I could define P2 is equal to P1, but now I'm going to put in my conversion factor. So I'm going to convert. I'm going to do an open bracket. And then I'm going to type in my units, where millimeters cubed times Pascal over minute, and then a comma, and I want to convert that to horsepower. So if I go ahead and click solve here, here's my answer. It was 22.35. And if you remember, this was quite a bear of a problem, but EES does it just fine. So here's this function convert, and I'll talk a little bit about the function. And it's going to essentially create a conversion factor for me. I give it two parameters, so a parameter, a comma, and a parameter. And there's particular units that EES knows, so it knows what a millimeter is. And this little hat symbol right there means that it's a to the power of, so to the power of 3 times a Pascal per a minute, comma, and then there's a horsepower. And so I could go ahead and do the conversion. Now, if I had typed something incorrect, and these units were not compatible, so for example, if I hadn't put that per minute there and attempted to solve it, I get an error, and it tells me that they're inconsistent, and it tells me that what the dimensions are. These are length, mass, time, LMT. So it tells me that that was wrong, so it kind of helps. But it's pretty easy in terms of conversion factors for solving this. Now, where these functions come from, EES has lots of them, so you can find them either in the help documentation or if you go up under options and function information, there's various types of functions. We're eventually going to get to these thermophysical properties. But first we'll look at the math and strings function right up here on the top and realize there's a whole bunch here. So ABS is absolute value, as you might guess, angle to degree conversions, stuff like that. And right down here is the one convert. So I can go ahead and click on convert. And then at the bottom here, it kind of gives me what this an example would be. So it has it written down here, convert. It gives me some sample units going from one to the other. You could go ahead and just paste that in there. Oops, that was kind of got stuck in the middle of my other equation because my cursor happened to be there. Okay, this is what it just pasted in there, and it says, here's an example, x equals convert, and it gave me some sample units there. So we could actually probably solve that, right? And there's my value of x, and that's converting from these units of BTUs per hour, foot squared R, watt per meter squared Kelvin. All right, so anyway, this is kind of an introduction to using both the simultaneous equation solver and the function convert. And in future videos, we'll start looking at some of the other functions and eventually get into the thermal physical functions.